Welcome back. Let's start off with the very first item on our list, bubble sort. Sounds kind of playful and nice, right? Bubble sort is part of these first three sorting algorithms here that are called elementary sorts. They're very simple, basic sorting algorithms that you would usually think of if somebody asked you to sort something at the top of your head. The second items here that we're going to get into later, merge sort and quick sort, are more complex algorithms that most of the time can be more efficient than the first ones. But to build that Lego block, let's start off with bubble sort. How does bubble sort work? Well, let me ask you a question. If I gave you a list and I asked you to sort it, in your head, imagining that you had blocks of these letters, how would you move them around? Or how would you tell a computer to move them around to sort it? And bubble sort might be one of the first things that comes into mind. You see, bubble sort comes from the idea of bubbling up the largest value using multiple pass-through. Let's see what I mean by that. We look at 6 and 5, and then say 6 is larger than 5. And then we look at 6 and 3, and say 6 is larger than 3, let's swap them out. Then we look at 6 and 1, and once again, 6 is larger than 1, let's swap them out. We look at 6 and 8. 8 is larger than 6, so keep it the way it is, and let's move on to the next one. 8 and 7, let's swap them out. 8 is larger than 7. 8 and 2, swap them out. 8 and 4, swap them out. We bubble up the highest number, and then we go from the beginning. 5 and 3, 5 and 1, we bubble up the largest number, so that 7 comes next. Then we keep going until 6 comes next. Then we keep looping until we bubble up the highest number one by one, until we have a sorted list. That is bubble sort. Now, before we even code this, what do you think of bubble sort? As you might have guessed, it's not the most efficient, is it? Look at how many comparisons we did, and everything was one by one, looping and looping and looping. And bubble sort is one of the simplest sorting algorithm, but also one of the least efficient. So don't hate me for showing you how this works. It's usually used as a learning tool as the first step in learning a sorting algorithm. What do you think the time complexity and space complexity of this algorithm is? The answer? Well, we can just use the big O cheat sheet. If we look at bubble sort, we see that the cases that we're most interested in is the average and worst case. We see that it's O of n squared with a space complexity of O of 1. We're not really creating any new data structures. We're just comparing items in nested loops one by one. But let's see it in code to see why this is O of n squared. And I want to challenge you here. In the next video, we're going to code along the bubble sort algorithm. But if you want, go ahead and try implementing this on your own and see how your code matches up with mine in the next video. I'll see you in that one. Bye-bye.